Hello everybody. In this video we're going to learn limit definition of derivative. We're going to do practice problems and master the topic. Here I have prepared the limit definition of derivative formula. So f prime of x is equal to limit as h is approaching to 0 f of x plus h minus f of x over h. No matter how simple or complicated, when we are starting a problem, first we're going to prepare f of x and f of x plus h. And then we're going to plug in f of x and f of x plus h values into the formula. Our main purpose is to cancel out the h in the denominator, because we would like to get rid of anything divided by 0 undefined position. And then we're going to clean up and simplify the equation. Let's begin with example 1. 2x plus 3. We know by heart the derivative of this function is equal to 2 because here our slope is 2. This is in the form of y equals to mx plus b, and derivative means the slope, and the slope here is 2. So we know that f prime of x is equal to 2. That means the derivative at every single point is 2. Graphically, that means if you pick up any 2 points and apply slope formula, which is delta y over delta x, which is y2 minus y1 over x2 minus x1, you obtain slope as 2 for this specific function. Now we're going to do limit definition of derivative. So our prep is f of x and f of x plus h. So f of x is given already. It is 2x plus 3, our original problem. F of x plus h is wherever we see x in the original problem, we're gonna substitute it with x plus h. That's what it means to say f of x plus h. So 2 times x plus h, so we substitute x with x plus h plus 3. And if you distribute 2 inside, you get 2x plus 2h plus 3. So this is our f of x plus h. Now we're going to plug that into our formula. So f prime of x is equal to limit as h is approaching to 0 f of x plus h minus f of x over h, and limit as h is approaching to 0 f of x plus h is 2x plus 2h plus 3, that's what we found, minus f of x, which is 2x plus 3. Don't forget to use parentheses because negative sign will be distributed inside all over h. Now we're going to simplify the numerator. So limit as h is approaching to 0, 2x plus 2h plus 3 minus 2x minus 3, if you distribute this negative sign inside, all over h. Now we're going to do necessary simplifications. So we have positive 2x, negative 2x cancels, 3 cancels, negative 3. So we're left with 2h over h. 2h over h is 2 because h cancels h, 2. So limit as h is approaching to 0, 2h over h is equal to 2. We already know it, that 2 was the derivative. Let's go to more complicated examples. Let's look at this example. F of x is equal to x squared. So our prep is f of x. F of x is given, which is x squared, and f of x plus h will be x plus h, the quantity squared, because wherever we see x, we replace it with x plus h. Now we need to distribute this. So it will be x squared plus 2xh plus h squared. So if you apply the formula a plus b, the quantity squared, you get a squared plus 2 times ab plus b squared. Or you can multiply x plus h times x plus h and then simplify. Now we're going to place f of x and f of x plus h values into our formula. So f prime of x is equal to limit as h is approaching to 0. F of x plus h, what we found is x squared plus 2xh plus h squared minus, don't forget to open up parentheses, and then f of x value is x squared all over h. Now this is going to be equal to limit as h is approaching to 0, x squared plus 2xh plus h squared minus x squared, because we're going to distribute this over h. Now we will do necessary simplifications. X squared cancels x squared. And then we're going to factor out h on top, because our main purpose is to cancel out on the bottom. So if we factor out h on top, we're left with 2x on the first term and h on the second term here. Now we can cancel h with h on the numerator. Now we can directly plug in 0 because we have no restriction anymore. So 2 times x plus 0 is the derivative. So f prime of x is equal to 2x. We already knew it, because if you apply the power rule, 2 comes in front, and then you subtract 1 from the power. So it will be 2 times x to the first power, which is 2x. Now we know that f prime of x is 2x. Graphically, that means the general formula for the derivative is 2x. If I would like to know what the derivative is at some specific point, let's say, what is the derivative at -1? So what is the derivative of this point? So I'm going to plug in -1 in our f prime of x formula. So derivative at this point is -2. So what is the derivative at 1/2? So f prime of 1/2 will be equal to 2 times 1/2. So derivative here is 1. So what we are doing is finding the derivative formula for general function. And if you would like to know the derivative at some specific point, then you need to plug in the x coordinate of that point into your f prime of x function. Let's see this example. F of x is 1 over x plus 1. Before we start the limit definition of derivative, let's use our advanced knowledge and see what our expectation will be for this problem. So f of x, let's rearrange this function, will be x plus 1 to the -1. If you take x plus 1 to the numerator, because this is +1 power, it becomes -1 power. Now we will apply the power rule. So power rule suggests take the power to the front and subtract 1 from the power. So we take -1 to the front and we subtract 1 on the power. So we obtain -x plus 1 to the -2. And if you rearrange this better, you obtain 1 over x plus 1 squared. So negative 1 over x plus 1 squared will be the derivative that we are expecting to find. Okay, now we're going to apply limit definition of derivative. We will start with the prep. Our f of x is the original problem. F of x is given 1 over x plus 1. F of x plus h is wherever I place x plus h into x in the original function. So it will be 1 over x plus h instead of this x plus 1. And if you rearrange this, 1 over x plus h plus 1. Now we will place everything into formula. So f prime of x is equal to limit as h is approaching to 0, f of x plus h, which is 1 over x plus h plus 1, minus f of x, which is 1 over x plus 1, all over h. Now we're going to do this subtraction between two fractions. So we need common denominator. We need exactly the same denominator to be able to merge this. So for this, we will multiply the whole equation on top by the common denominator, which is x plus h plus 1 times x plus 1. So if I multiply this whole common denominator by the first fraction, I obtain this x plus h plus 1 cancels that. So 1 times x plus 1 is left from the first fraction. And from the second fraction, if we multiply again the second fraction by the common denominator, this time x plus 1 cancels x plus 1, and we multiply x plus h plus 1 by 1, so that is x plus h plus 1, and all over the common denominator, which is x plus h plus 1 times x plus 1, and everything is over h. Now we will do necessary simplifications on top here. And every time don't forget to write limit as h is approaching to 0. So we have to distribute this negative sign inside. So negative times x is negative x, negative times h is negative h, and negative 1 here. Now we can cancel out positive x and negative x, positive 1 and negative 1, so negative h is left on the numerator here. On the denominator, we have x plus h plus 1 times x plus 1, and we have h on the denominator here. So this is a complex fraction, so we can do keep, change, flip. Keep the first fraction, change division to multiplication, and flip the second fraction. So limit as h is approaching to 0, negative h over x plus h plus 1 times x plus 1 times 1 over h. Now h cancels h, and limit as h is approaching to 0, we have negative 1 on top, and x plus h plus 1 times x plus 1 on the bottom. Now we have no restriction to plug in h as 0 because we are not going to obtain anything over 0 division. So negative 1 x plus 0 plus 1 instead of h times x plus 1. So that will be equal to x plus 1 times x plus 1, which is desired negative 1 over x plus 1 quantity squared. So this is our derivative. So our general formula for derivative f prime of x is equal to negative 1 over x plus 1 the quantity squared. So if you would like to know what the derivative is at 0, then we have to plug in 0 into x. So f prime of 0 is equal to wherever x is 0, so it will be negative 1 over 1, which is negative 1. So derivative at f prime of 0 is negative 1. So if you would like to know what the derivative is at specific point, you're going to plug it in the x coordinate here. On problem number 4, we're going to take the derivative of square root of 2x plus 9 using limit definition of derivative. Before we do that, let's take the derivative using our normal derivative knowledge and compare the expected answer. So we can express square root of 2x plus 9 as 2x plus 9 to the power of 1/2. That's what square root means. So we can apply the power rule and the chain rule. So we can bring 1/2 to the front, subtract 1 from the power, and multiply by the derivative of the inside function. So derivative of 2x is 2 and derivative of 9 is 0. So here 2 cancels 2 and 1/2 minus 1 is negative 1/2. So 2x plus 9 to the negative 1/2 is our answer. And if you would like to rearrange it, you can bring that to the denominator, which is 2x plus 9 to the positive 1/2. And you can express 1/2 as square root again back. So 1 over square root of 2x plus 9 is our expected answer. So we are expecting to find 1 over square root of 2x plus 9 using limit definition of derivative. Okay, so f prime of x is equal to limit, as h is approaching to 0, f of x plus h minus f of x over h. So we need to write f of x, which is square root of 2x plus 9, and f of x plus h is square root of 2 times x plus h plus 9. So in the original function, wherever we see x, we're going to substitute it with x plus h. Now we can distribute 2 inside, so we get 2x plus 2h plus 9. Now we can place those f of x plus h and f of x in our limit definition of derivative. So we have 2x plus 2h plus 9 minus 2x plus 9 all over h. For these type of limits, we're going to multiply both top and bottom by the conjugate of the numerator. So we're going to multiply this fraction by the conjugate of the numerator, so we can rationalize these square roots. So 2x plus 2h plus 9 plus 2x plus 9 over 2x plus 2h plus 9 plus 2x plus 9. So conjugate means, let's say you have a plus b, then the conjugate is a minus b. If you have a minus b, then the conjugate is a plus b. Now we can go ahead and multiply numerators and denominators. On top we have a minus b kind of term times a plus b kind of term. So by definition, a minus b times a plus b is a squared minus b squared, which is difference of two squares. So for this formula, our a term is the first term and our b term is the second term. So we're going to square the first term. So limit as h is approaching to 0, the square of the first term, square cancels the square root, so 2x plus 2h plus 9 minus square of the second term, 2x plus 9 and on the bottom we have h times 2x plus 2h plus 9 plus 2x plus 9. Now we're going to distribute negative sign inside. So negative times this is negative 2x, and negative times this is negative 9. Negative 9 cancels positive 9. 2x cancels 2x. We're left with 2h over h times this expression. Now h cancels h. So we're left with 2 on top and square root of 2x plus 2h plus 9 plus 2x plus 9 on the bottom. Now we can directly plug in h as 0, so that makes this 0. So we have 2x plus 9 in radical plus 2x plus 9 under radical. We have 2 of them, so 2 over 2 times 2x plus 9, limit as h is approaching to 0. So we have no h term here, there is nothing to do with h. So we can cancel 2's and we're left with 1 over 2x plus 9 under the radical, and that is answer that we were expecting. On problem number 5, let's see 1 over x squared. So our f of x is 1 over x squared. And our f of x plus h is 1 over x plus h squared. So if we distribute this, we're going to get x squared plus 2xh plus h squared, because a plus b squared is equal to a squared plus 2 times ab plus b squared. Or you can write x plus h 2 times and FOIL it. Now our ingredients are ready, so we can start. So f prime of x is equal to limit as h is approaching to 0, f of x plus h, which is 1 over x squared plus 2xh plus h squared, minus 1 over x squared all over h. Now we're going to merge these two fractions by multiplying the common denominator. So the common denominator is x squared plus 2xh plus h squared times x squared. So the common denominator times the first fraction gives us, this cancels that, 1 times x squared, which is x squared, minus the common denominator times the second fraction gives us 1 times x squared plus 2xh plus h squared, and everything all over the common denominator, which is x squared plus 2xh plus h squared times x squared, and everything is all over h. Now we're going to distribute this negative sign into the second fraction we obtained here and then simplify. So limit as h is approaching to 0. So that x squared cancels this x squared because negative sign makes this negative, and we obtain negative 2xh minus h squared. So negative 2xh minus h squared over this common denominator we had before, all over h. So we have a complex fraction here, so we can do keep change flip. Keep the first fraction, change to multiplication, flip the second fraction. So we can continue as limit h is approaching to 0. Our first fraction is negative 2xh minus h squared over x squared plus 2xh plus h squared times x squared times we flip the second fraction, 1 over h. Here our main purpose is to cancel h, so we get rid of the 0 denominator. So here we can factor out h. We can factor out negative h actually. So 2x plus h left inside. So h cancels h, so we're left with negative 2x plus h over x squared plus 2xh plus h squared times x squared. Now we have no restriction for directly plugging in. We can plug in h as 0. So that is 0, this is 0, and this is 0. So we have x squared times x squared, which is x to the 4th. This x cancels one factor of x here, so x to the 3rd. So negative 2 over x to the 3rd is our final answer. So using limit definition of derivative, we found the derivative of 1 over x squared as negative 2 over x cubed. Let's see, using our derivative knowledge, if it is true or not. So our function is 1 over x squared. So the derivative of that function will be, let's write x squared as x to the negative 2 if we bring it up, and we can apply the power rule. So negative 2 comes to the front, and we subtract 1. So now what we obtain is negative 2x to the negative 3rd, and we can bring this to the bottom, negative 2 over x to the 3rd. That is correct. In this video, we tried to study limit definition of derivative, and I have checked some main examples. If you think me to solve different kind of examples, please send me on the comment below. Thank you very much.